Hello guys, today we are going to show how we took data for Wheatstone bridge experiment. For this experiment, we used power supply, galvanometer, resistance box, 5 different coils, and Wheatstone bridge table, where we have like a long 1 meter wire and we have like moving wire. So the goal of this experiment is to determine the unknown values. So Wheatstone bridge helps us to find the unknown values, and as an unknown resistance values would be our 5 different coils. So we are going to find the resistance values for these 5 different coils. So we already set up our system, and we are going to use this galvanometer. So galvanometer itself is a very sensitive ammeter. So when it goes to 0, we can say that the bridge is in equilibrium position. In other words, there is no current passing through the galvanometer. Alright, so now let's get started of filling our data table 1. So here we have like 5 different coils and this L1 and L2 values. So L1 and L2 values is basically the range or the distance of this wire when the galvanometer is 0. So here we already set our system to coil number 1, and now we are going to bring this galvanometer to 0 by moving this moving wire. Okay, so let's get started from the center when it's 50. So as you can see, it's inclined in this position, so that means we should go in that way. So as you can see, it approached to 0, and if we go further, it will go in that direction. So our point is to come to 0. Yeah, there we go. And now let's measure the L1 values. As you can see, the L1 value is 35.7. Okay, so 35.7, and L2 would be just you must subtract 35.7 from 100, so it would be 64.3 centimeters. So you should also define the units here. And now we are going to find the ratio L1 over L2. So 35.7 over 64.3, and the ratio is 0.55. And also we already set, for example, here the value for known value, which is 0.1, 0.2 and 0.3 are all on. That means in total we have 0.6 ohms, whether others are off. So here we should write 0.6, which we already did. So in order to find this unknown value, you must use this formula. So currently here we already calculated the ratio, and we must multiply by RS. So if you multiply these two values, you would get 0.33 ohms. And now next we must measure the value of unknown resistance of coil number 1 directly. So what I mean directly is we are going to measure with ohm meter. Okay, so alright, so currently we are measuring 0.8. So the value is, yeah, we can say it's 0.8 ohms. So yeah, as you can see, we're supposed to get 0.8, but we received 0.33. It's a little bit off, but that's fine. Okay, so for data table 2, we are going to just switch places of our unknown value, I mean these coils, and the place of resistance box. Okay. Okay, so okay, now let's try to measure again. So as you remember, our goal was to set the galvanometer to 0, right, and to find the L1 and L2 values. Now we are working for this data table 2. Okay, so yeah, so here as you can see, we should go this direction in order to reach 0. So yeah, we are approaching to 0. And the value, yeah, there we go. So the value is, as you can see, 46.5. Okay, so here I'm feeling 46.5, and this value would be 53.5. And here, since we switched the places, our formula also would change. You see, the ratio would be L2 over L1, but previously it was L1 over L2. So now we are going to find the ratio of these two. So let me quickly find these ratio values. 53.5 divided by 46.5 will give us 1.15, and we didn't change these RS values, it was 0.6, and if you multiply this ratio by 0.6, we would get 0.69, and our with multimeter we already measured 0.8. So this is how it works. So this procedure you should repeat for different coils. Like we have copper. These are all copper, but the last one is nickel and silver. So the differences between them is the diameter, the length of these wires, and so on. So by using this data table 1 and data table 2, you're supposed to fill data table 3. So here, for example, Rx multimeter would be the same, right? 0.8. But average of Rx values, you should use this average of these two and fill your table. So let me quickly find the average of these two, and I found like 0.51. And for resistivity, so length and radius, cross-sectional area, you can find those informations from table 2, which is given in your lab manual, okay, for different copper, for different coils. So like coil number 1, and by number is already given. And in order to find the resistivity, you should use this formula, okay? R equals resistivity times length over cross-sectional area. So you should find from this equation the resistivity, and you must compare later with accepted resistivity values and find the percent error, okay? So accepted resistivity values you can find from here. For example, we used copper, and let's find the copper from here. It's, as you can see, it's 1.7. so make one more column here, okay, for percent errors.